Welcome to Rhythm Classroom. शुरू करते हैं Chemistry Part 1 textbook for Class 11 of NCERT. Unit 1, Some Basic Concepts of Chemistry. First question is,
calculate the molar mass of H2O, CO2 and CH4. First of all, let's take up H2O. H2O consists of 2 hydrogen and 1 oxygen atoms. Atomic mass of hydrogen is equal to 1 U, that is atomic mass unit. We have 2 molecules of hydrogen in H2O, therefore we have 2 multiplied by 1, equal to 2 U mass of hydrogen in H2O molecule. Similarly, 1 atom of oxygen having atomic mass of 16 U has a total of 16 U in the H2O molecule. Thus molecular mass of H2O becomes 16 U of oxygen plus 2 U of hydrogen, that is 18 U. It is a thumb rule, students, that molar mass of a substance in grams is numerically equal to its molecular mass in atomic mass unit. Thus, molar mass of H2O becomes 18 grams. Next is CO2. There is 1 carbon and 2 oxygen atoms in it. Atomic mass unit of carbon is 12 U, while that of oxygen is again 16 U. Thus molecular mass of CO2 comes out to be addition of 12 U and 2 times 16 U, that is 44 U. Hence molar mass of CO2 can be written as 44 grams. In case of CH4, there is 1 carbon atom which has an atomic mass of 12 U, while the 4 hydrogen atoms have combined mass of multiplication of 1 U with 4, that is 4 U. Adding the 2 masses, we get a molecular mass of 12 U plus 4 U, equal to 16 U in CH4. Thus, molar mass of CH4 becomes 16 grams. Question number 1.2 is, calculate the mass % of different elements present in sodium sulfate. Similar to calculation in previous question, molar mass of sodium in Na2SO4 comes out to be 46 grams, of sulfur, 32 grams, and of oxygen, it comes out to be 64 grams. Molar mass of Na2SO4 becomes the sum of the molar masses of the 3 components, which is 46 plus 32 plus 64 equals 142 grams. Now let's calculate the percentage. Percentage of sodium comes out to be 46 divided by 142 times 100, equal to 32.39%, of sulfur is 32 divided by 142 times 100, equal to 22.54%, and of oxygen, it is 64 divided by 142 times 100, equal to 45.07%. As a cross-check, sum of all the percentages should be 100%. Third question is, determine the empirical formula of an oxide of iron, which has 69.9% iron and 30.1% dioxygen by mass. It should be known to you that atomic mass of iron is 55.85 U and that of oxygen is 16 U. Therefore, molar mass of iron becomes 55.85 grams per mole and that of oxygen, 16 grams per mole. In other words, number of atoms in 55.85 grams of iron equals 1 mole and in 16 grams of oxygen, 1 mole. Mathematically, number of atoms in 1 gram of iron are 155.85 of a mole, while in 1 gram of oxygen, 1/16 of a mole. As per the question, 100 grams of oxide contains 69.9 grams of iron and 30.1 grams of oxygen. Therefore, again mathematically, number of iron atoms in 69.9 grams equals 69.9 divided by 55.85 moles, and in 30.1 grams of oxygen, 30.1 divided by 16 moles. On calculation, it comes out to be 1.25 moles of iron and 1.88 moles of oxygen. Dividing all values by the lowest number, which is 1.25, we get the ratio of iron to oxygen to be 1:1.5. Since the ratio is expressed in whole numbers, we will multiply all values by 2 to convert them into whole numbers. This means that, for every 2 atoms of iron, there are 3 atoms of oxygen in the oxide. In this way, empirical formula of the oxide becomes Fe2O3.
question number 1.4 is, calculate the amount of carbon dioxide that could be produced when a. 1 mole of carbon is burnt in air. B. 1 mole of carbon is burnt in 16 grams of dioxygen. C. 2 moles of carbon are burnt in 16 grams of dioxygen. Let's take up part A. हमें पता है कि 1 atom of carbon, when burned in oxygen, gives 1 molecule of carbon dioxide. Therefore, 1 mole of carbon atoms will produce 1 mole of carbon dioxide molecules. It can be calculated that mass of 1 molecule of carbon dioxide comes out to be 12 plus 2 times 16 equals 44 atomic mass units. Therefore, mass of 1 mole of carbon dioxide molecules can be written as 44 grams. Thus, 44 grams of carbon dioxide is produced when 1 mole of carbon is burnt in air. In part B, we have limited amount of oxygen, that is 16 grams. Let's revisit the chemical equation and find out the molecular masses of reactants and products. For 1 mole of carbon atoms, it can be rewritten as. Thus 1 mole of carbon requires 32 grams of oxygen to produce 44 grams of CO2. But we are provided with only 16 grams of oxygen. Thus, carbon dioxide produced when 1 mole of carbon is burnt in 16 grams of oxygen can be calculated as 44 divided by 32 times 16, equal to 22 grams. In next part C, number of carbon atoms are doubled to 2 moles while amount of oxygen remains the same. As we calculated in 1.4b, 12 grams carbon reacts with 32 grams oxygen to give 44 grams carbon dioxide. We have seen that mass of 1 mole of carbon atoms equals 12 grams. Therefore mass of 2 moles of carbon atoms equals 2 times 12 grams equals 24 grams. Thus carbon required for reacting with all of the available 16 grams oxygen equals 12 divided by 2 equals 6 grams. Therefore out of 24 grams carbon, 6 grams carbon reacts with all available oxygen while remaining 18 grams of the carbon remains unreacted. As calculated in 1.4b, carbon dioxide produced is again 22 grams. Hope the class was helpful to you. Any doubts or queries may be written in the comments section. I might be coming up with more such sessions in future on this channel. Till then, goodbye and see you soon.